ECE 2024 question paper conducted by Andhra Pradesh Public Service Commission Part 2 continuation. Compute the average power transmitted for a frequency modulated wave if carrier amplitude is 10 volts and frequency deviation is 100 Hz. Given frequency modulated signal, the signal is frequency modulated. For a frequency modulated signal, average power is average power in frequency modulated signal is given by P average is equal to AC square by 2, where AC is the amplitude of carrier. Carrier has an amplitude. Carrier signal amplitude is given by AC, that is 10 square by 2, 50 watt. Average power in FM signal is P average is equal to AC square by 2, that is 50 watt. In FM signal, the power in FM signal is constant irrespective of modulation index, because in FM signal the variations are in terms of frequency but not in terms of amplitude. Next question. Question 32. So given spectrum is given, spectrum of message signal, and this is a spectrum of carrier signal C of t. Let us see some points related to spectrum. Modulation scheme. Conventional amplitude modulation or double sideband full carrier modulation. Its spectrum consists of frequency component, upper sideband and lower sideband. Similarly, double sideband suppressed carrier. So carrier is suppressed. It consists of only upper sideband and lower sideband. Next is SSB-SE, single sideband suppressed carrier modulation. In single sideband suppressed carrier modulation, it consists of only LSB or only USB. It consists either lower sideband or upper sideband. Vestigial sideband modulation, it consists of one sideband, either LSB or USB, plus a part of vestigial frequency. So that is vestigial sideband modulation. In the given graph, the spectrum of modulated signal consists of carrier frequency FC, upper sideband frequency and lower sideband frequency. So this is a spectrum of double sideband full carrier modulation, or spectrum of standard AM signal, spectrum of double sideband full carrier. It is also called as conventional AM, either it is called standard AM signal or DSB FC signal or conventional amplitude modulation. First option is the correct one. Next question. Consider the following statements in the context of modulation and demodulation related to single sideband modulation, SSB modulation. SSB modulation is sometimes referred to as frequency changing or frequency mixing or simply heterodying. The statement is correct because heterodying is a signal processing technique that creates new frequencies by combining or mixing of two frequencies. Let us see the block diagram of SSBSE modulator. In SSBSE modulator, message signal and carrier signal is applied to either balanced modulator or ring modulator that generates DSBSE signal. The DSBSE signal is again passed through a low pass band pass filter to select a particular band of frequencies, either upper sideband or lower sideband, which results in SSBSE signal. The output is SSB. The output of band pass filter is SSB SE signal. So it is nothing, some frequency conversion is taking place in the SSBSE modulation scheme. Statement P is correct. Statement Q. The bandwidth of vestigial sideband modulation is less than average message signal bandwidth. This statement is false. The bandwidth of vestigial sideband modulation is slightly more than message signal bandwidth, because in here the bandwidth in conventional amplitude modulation is 2 FM. The bandwidth of DSP-SC is also 2 FM. FM is the highest frequency component of message signal. In SSB-SC, the bandwidth is FM. In vestigial sideband modulation, it is FM plus FV. So in vestigial sideband modulation, bandwidth is slightly higher when compared to message signal bandwidth. Next question. Identify the following circuit in communication. So this circuit is COSTAS receiver, which is used for generating the DSBSC signal. There are two detectors coupled together to form a negative feedback system designed in such a way as to maintain the local oscillator synchronous with the carrier wave. The detector in the upper path is referred to as in-phase coherent detector. This is high channel or in-phase coherent detector, and the detector in lower path is referred to as quadrature phase. Quadrature phase coherent detector or Q channel. So upper path is in-phase coherent detector or I channel. Lower path is quadrature phase coherent detector or Q channel. And this COSTAS receiver is a practical synchronous receiving system suitable for demodulation of DSBSC waves. By combining I channel and Q channel output in the phase discriminator, a DC control signal is obtained. So this is I channel output, and Q channel output in a phase discriminator. A DC control signal is obtained which automatically corrects for local oscillator phase errors. Here message signal is applied, message signal M of t is applied to a product modulator, but the product modulator in the I channel signal given is cos 2 pi fct plus phi, but 90-degree phase shift signal is given to the product modulator in the Q channel, and finally demodulated output is obtained here. Demodulated output is obtained. If phase phi is 0, then in phase component is half AC cos pi m of t, and quadrature component phase is 0. If phase phi exists, then in phase component and quadrature phase component exist, where quadrature phase component is AC sin phi m of t. This is some points related to COSTAS receiver, which is used for demodulation of DSBSC signals. Next question. An eye opening of dash corresponds to an intersymbol interference. When there is no ISI, the eye opening is unity. When there is no ISI, the eye opening is said to be the eye opening is unity. When there is a significant amount of ISI, the eye opening is 0. An eye opening of 50% or signal to noise ratio of 6 dB, signal to noise ratio of 6 dB or more, allows reliable data transmission. Wider eye opening indicates lower error rates, and narrow and more closed eye indicates higher rates. Eye opening is 0 means significant amount of ISI, that is significant overlap between symbols, no clear distinction between symbols. There is no clear distinction between transmitted symbols. So this is the eye diagram in which the width of the eye opening defines the time interval over which the received wave can be sampled without error from the intersymbol interference, and the height of the eye opening at a specified sampling time determines the margin of the noise. Height determines noise margin, and width of the eye determines the time interval over which the received waveform can be sampled without error from the intersymbol interference. and the sensitivity of the system to timing error is determined by the rate of closure, that is shape of eye opening as a sampling time is varied. The width of the eye opening, middle eye, rate of closure of the eye is completely closed. Different cases are given, and this is a eye diagram. Interpretation of eye diagram. So for this question, the correct answer is 1. An eye opening of unity corresponds to zero intersymbol interference. Next question. Entropy is defined in terms of probabilistic behavior of source information. So correct. So entropy is average information content per source symbol. Entropy is average information content per source symbol. So entropy is maximum if all symbols are equiprobable. Entropy is maximum if all symbols are equiprobable. If the probability of all symbols are same, then entropy is maximum. Entropy is average information content per content average information content for given source symbol. Entropy is defined in terms of probabilistic behavior of the source symbol. Next statement 2. The capacity is related to intrinsic ability of channel to convey the information with respect to noise characteristics of the channel. Statement 2 is also correct. The statement 2 defines the channel capacity is defined as maximum rate of reliable information over the channel. Maximum rate of reliable information over the channel. If C is a C greater than or equal to RH for reliable data transformation or transmission. For reliable data transmission, C greater than or equal to RH. That is, let C be the capacity of discrete memoryless channel. H is the entropy of the discrete memoryless source emitting R symbols per second. The capacity theorem states that if RH less than or equal to C, then there exists a coding scheme such that output of source code can be transmitted over the channel with an arbitrarily small probability of error. The converse of this is if RH greater than C, if RH greater than channel capacity, then it is not possible to transmit messages without error. Not possible to transmit this information without error. For reliable data transmission, as per channel capacity theorem, C capacity should be greater than or equal to RH, where R is symbols per second, number of symbols emitted per second, and H is the entropy of the source. So implications are channel capacity C is given as B log to 1 plus signal to noise ratio. So it gives the upper limit for the rate of reliable information transmission over the Gaussian channel. For a specified channel capacity, it defines a way in which the transmission bandwidth may be traded off for improved signal to noise ratio and vice versa. So these are the points related to channel capacity. Both statements are correct. Next, transition probability matrix is as follows. So this is a binary symmetric channel with symbol x1 is 0 and x2 is 1, and output symbols this x1 x2 are input symbols, y1 y2 are this y1 y2 are output symbols, and the probability is p of y by x, 1 minus p and 1 minus p. This is the probability matrix. The channel is symmetric because the probability of receiving 1 if 0 is sent is same as the probability of receiving 0 if 1 is sent. This common transition probability is defined by P. Here P defines a common transition probability between input and output. For binary symmetric channel, so these conditions are satisfied. P of y is equal to 0, x is equal to 1 is P of y is equal to 1, x is equal to 0 is P. P of y by x is a this P of y by x denotes the probability of y to be received provided x was transmitted. So probability of y to be received provided when x was transmitted. Next, a channel is said to be asymmetric if p of 1 by 0 not equal to p of 0 by 1. But the given channel is binary symmetric channel. The given channel is binary symmetric channel. Next question. Differential pulse code modulation exploits lossy data to remove redundancy inherent in the message, and demodulation and delta modulation is simplest form of differential pulse code modulation. So let us see the modulation and demodulation diagrams for differential pulse code modulation. So predicted circuit in DPCM is replaced with delay element in the delta modulation. That is one bit quantizer in the delta modulation. So this is a prediction filter and it is replaced with delay element. Here in delta modulation we are using one bit quantizer. Next. So differential pulse code modulation employs lossy data compression to remove redundancy in the inherent message by predicting and encoding the difference between the samples. Differential pulse code modulation works on the principle of prediction. So delta modulation is an easy way of differential pulse code modulation, or a simplest form of differential pulse code modulation that uses one bit data stream to transmit the information. In delta modulation technique, the difference between consecutive samples are encoded into n-bit data streams. Differential pulse code modulation is a technique that uses lossy data compression to avoid or to remove redundancy in the inherent message signal, making it more efficient for transmission and storage. This DPCM is used for speech, audio, image, where some loss in fidelity is acceptable to achieve the compression. So, delta modulation is the simplest form of differential pulse code modulation that uses one bit data stream to transmit the information. Next question. Option A is a correct here for 38 question. Question number 39. In FDMA, frequency bands are used to act as buffer zones buffer zones, which are necessarily because because of the impossibility of achieving ideal filter characteristics. So first option is correct. It is impossible to design ideal bandpass filters. This is bandpass filter with cutoff frequency FC1 and cutoff frequency FT2. So this is an ideal filter. Practically, the filter characteristics will be like this. So this is a practical filter. So it is impossible to achieving the ideal filter characteristics. Practical filter characteristics will be like this. So we are using some guard bands between the signals. So guard bands are small frequency bands used to prevent interference. These guard bands are small frequency bands left unused. These guard bands are left unused. Small frequency bands used to prevent interference between users. So no information is transmitted. This spectrum is not utilized. Guard band spectrum is not utilized. Next question. Pulse amplitude modulation is a linear modulation scheme where amplitude of pulses are varied in accordance with the value of message signal. Samples of continuous signal. So pulse amplitude modulation. So this is a waveform for PAM signal. In pulse amplitude modulation, the amplitude of the pulses are varied in accordance with the amplitude of message signal. In pulse width modulation, the width of the pulse is varied in accordance with the magnitude of message signal. In pulse position modulation, the position of the pulse are varied in accordance with the magnitude or amplitude of the message signal. So this is periodic pulse train, message signal M of t, PAM, pulse width modulation, pulse position modulation. This pulse width modulation is also called pulse duration modulation. So this pulse amplitude modulation is linear modulation scheme. PAM is linear modulation scheme, whereas PDM, pulse duration modulation, or pulse width modulation, pulse position modulation, these are non-linear modulation schemes. So similar, just like amplitude modulation is linear modulation scheme, just like AM is amplitude modulation is linear modulation, whereas FM and PM, that is angle modulation. Angle modulation is it is either FM or PM. So this is non-linear. PAM is a linear where amplitude of pulses is varied in accordance with the amplitude of message signal. Next question. So mutual information is expressed in terms of channel input, that is I of x by x is to y is equal to h of x minus h of x by y. Our mutual information can be expressed in terms of channel output, that is I of xy is equal to h of y minus h of y by x. Mutual information of the channel is related to okay. Mutual information of the channel is related to joint entropy of the channel input and output, or I of x is to y is h of x plus h of y minus h of xy. This is mutual information in terms of channel input, mutual information in terms of channel output, mutual information in terms of joint entropy. This, this h of x represents uncertainty about the channel input before observing the channel output. H of y represents uncertainty about the channel output before observing the channel input. H of y by x, that is conditional entropy, h of y by x and x by y. These two are conditional entropies. It represents the amount of uncertainty about the channel input after the channel output has been observed. Next, h of x minus h of y is uncertainty about the channel input that is resolved by observing the channel output. H of y minus h of x is uncertainty about the channel output that is resolved by observing the channel input. The conditional entropy h of x by y is, it represents amount of uncertainty about the channel output after channel input has been observed. So some properties of mutual information are: mutual information is symmetric. This mutual information I of xy is symmetric. So that is I of xy is equal to I of yx. So first property is this mutual information is symmetric and it is non-negative, always a positive quantity. I of xy greater than or equal to 0. So this is about mutual information. So I of xy is in terms of mutual information in terms of input, mutual information in terms of output, as well as mutual information in terms of joint entropy of the channel input and channel output. Joint entropy of channel input and channel output. Next question. In maximum likelihood detection, the probability of symbol error depends slowly solely on the relative Euclidean distance between the received signal point and message point in the constellation. So the statement is correct. So the AWGN is elliptically symmetric in all directions in signal space. So this signal space representation of AWN channel is a set of vectors that represents a signal, and AWGN is spherically symmetric in all directions. So this is not elliptically, it is spherically symmetric in all directions in the signal space. So it is spherically symmetric in all directions in signal space is due to its covariance matrix. Spherically symmetric it is due to its covariance matrix being proportional to identity matrix. AWGN noise distribution is uniform And AWGN is spherically symmetric in all directions in the signal space, and the reason is due to covariance matrix being proportional to the identity matrix. So P is correct and statement Q is incorrect. Next question. Given signal pulse phi of t, it's an LTI system with impulse response is said to be matched filter. So it is said to be matched. So matched filter. So matched, first we will see the definition of matched filter. Matched filter is a filter whose impulse response is time reversed and delayed version of time reversed and time reversed and delayed version of input signal complex conjugate. Delayed version of complex conjugate input signal. So this is the definition for matched filter, that is h of t is equal to phi star of capital T minus small t, where capital T is the time period of the signal. So that is 0 less than or equal to t less than or equal to t less than capital T. Matched filter has maximum energy of the signal at small t is equal to capital T. So that is amplitude is maximum. Impulse response of the matched filter. If the signal S of t is complex signal, then impulse response h of t is complex conjugate of input signal applied, time delayed and reversed signal. S star of capital T minus small t. If the signal input signal is imaginary, then impulse response is minus S of capital T minus small t. If the signal is real signal, then S of capital T minus small t. So these are the impulse response if signal is imaginary, if signal is complex conjugate, and signal is real. So different impulse responses for different signals. So first option is correct. A filter is said to be matched filter whose impulse response is time reversed and delayed version of input signal or input signals complex conjugate. Next, the dependence of information capacity of the channel is linear. Statement is correct. So the channel by channel with the channel Shannon's channel capacity theorem states that C is equal to bandwidth log base to 1 plus signal to noise ratio. So here capacity C is proportional to bandwidth and capacitance C is proportional to log to 1 plus signal to noise ratio. The capacity C and bandwidth have linear relation. The relation is linear, and for signal to noise ratio the relation is logarithmically connected. The information capacity C logarithmically depends on signal to noise ratio. The capacity C and channel bandwidth is linear. Both statements are correct. Next question. So the output signal here is BFSK signal, binary frequency shift keying signal, BFSK signal. If input is binary data, on off level encoder is given. So here the output of on off encoder is root EB for bit 1 and 0 for input bit 0. And this BFSK is nonlinear modulation scheme, where final output signal B is SI of t is equal to square root of 2 EB by TB cos 2 pi Fi of t. There are two frequencies we are using here. I is an integer, either 1 or 2, F1 or F2. EB is a transmitted bit energy and Fi is a transmitted frequency. This is a block diagram of BPF, BFSK modulator. Next question. Syndrome depends only on error pattern and not on the transmitted code word. So statement is correct. Syndrome vector is a mathematical tool. Let us see syndrome. Syndrome vector is a mathematical tool used in linear block codes to detect and correct errors in the received code words. Non-zero syndrome indicates the presence of errors, and syndrome is a function of error vector, not on the transmitted code word. So it is a function of error vector, but not on the but not the transmitted code word. All error patterns in the syndrome differ by a code word have same syndromes. So statement Q is wrong. All error pattern that differ by a code word have same syndrome. Let us see the properties of syndrome. Syndrome depends only on the error pattern but not on the transmitted code words. All patterns that differ by at most by a code word have same syndrome. Zero syndrome vector indicates Zero syndrome vector indicates that received vector is error free. If syndrome is zero, there is no error. Next, syndrome error vector is a binary vector. It is a binary vector used to identify used to identify the location and presence of errors. Location and presence of errors in received code word. So syndrome can be defined as a mathematical tool used in linear block words to detect and correct errors in the received code words. Non-zero syndrome indicates the presence of errors. Syndrome is a function of error vector, not the transmitted code word. Statement P is correct, Q is wrong. Next, Hoffman coding. So this is algorithm of Hoffman coding. This Hoffman coding is a variable length code and it results in optimum coding. Hoffman coding results in optimum code. The efficiency of Hoffman coding is greater than efficiency of Shannon-Fano coding. Hoffman code is a source code whose average word length approaches to the fundamental limit set by the entropy of discrete memoryless source. Hoffman coding is optimum in the sense that no other uniquely decodable set of code words has smaller average code word length for a given discrete memoryless source. Let us see the algorithm for this Hoffman coding. The source symbols are listed in the order of decreasing order of probability. Given source symbols, they has to be written in decreasing order of probability. So that is 0.4, 0.2, 0.2, 0.1 and 0.1. First step is done. Next step. The two source symbols are regarded as being combined into a new source symbol with the probability equal to sum of two original probabilities. The probability of new symbol is placed in the list in accordance with its value. Next step is second step is repeated until it reaches the procedure is repeated until we are left with the final list of source statistic symbols of only two which are either 0 or for which 0 and 1 is assigned. The second step is repeated. So that is 0.4. These two source symbols are added. 0.2 is a probability of the source symbol 0.2 and then remaining symbols written as it is 0.2 0.2. So this 0.2 correspond to this symbol, this 0.2 correspond to this symbol. Again same step, the lowest source symbols are added and placed in the descending order. 0.4, next 0.4, 0.2. This 0.4 is placed here, this 0.2 is placed here. Step 2 is repeated until only two symbols are left. So this 0.4 is placed here. Now 1 and 0 is assigned to the symbols which are left. This is assigned with 0 and this is assigned with 1. The procedure is repeated until we are left with a final list of source statistics or symbols of only two for which 0 and 1 is assigned. There are only two symbols in the last column and 0 and 1 is assigned, and then backtracing. The code for each source symbol is found by working backward tracing of the sequences of ones and zeros assigned to that symbol as well as its successors. So for this 0.4 the symbol is 0 0. For here it is 0 1. Next For this 0.4, it is assigned with 1. It is 0, 0, 1, 0, 1, 1. Next, for these symbols, 0, 1, 1, 0, 1, 0. The correct option is A. For 0, 4, it is 0, 0. Next, for 0, 2, 1, 0, 1, 1, 0, 1, 0, and then 0, 1, 0, 1, 0, 0, 1. For 0, 2, it is 1, 1. For again 0, 2, it is 0, 1. Next question. Consider the following statements in the context of Coulomb's law. Coulomb's law states that force of attraction between 2 point charges or the force between 2 point charges q1 and q2. Coulomb's law states that force between 2 point charges q1 and q2 is directly proportional to product of charges. Force is directly proportional to product of charges q1 and q2, and force of attraction or force is inversely proportional to 1 by d square, and this force is acting along the line joining them. There are three conditions. One is force is directly proportional to product of charges. Force is directly proportional to product of charges, and force is inversely proportional to square of distance. Square of distance between the point charges or charges, and force acts along the line joining them. Line joining the charges acts along the line joining the charges or simply joining them. So this is Coulomb's law. Now force of attraction is given is proportional to q1 q2 by d square, and the proportionality constant is 1 by 4 pi epsilon naught q1 q2 by d square newtons, where 1 by 4 pi epsilon naught is its value. The value of 1 by 4 pi epsilon naught is 9 into 10 power 9, and epsilon naught is permittivity whose units are farad per meter. So correct option is both P and Q are correct. Force is directly proportional to product of the charge values and inversely proportional to square of the distance between the charges. Next, boundary conditions. The tangential component of electric field across the interface is continuous. That is ET1 is equal to ET2. So we know that D is equal to epsilon E. So with this, dt1 by epsilon 1 is equal to dt2 by epsilon 2. So from this, dt1 is equal to epsilon 1 by epsilon 2. Tangential component of electric flux density is related by like this. Tangential component of electric field is continuous, but the tangential components of electric flux density is discontinuous. Similarly, for normal components, so A is B is 1. Next, C is 4. Epsilon 1 by epsilon 2, C is 4. Next is normal components. So normal component of electric flux density is dn1 minus dn2 is equal to rho s, surface charge density, where rho s is surface charge density, d is epsilon 1 epsilon en1 minus epsilon 2 en2 is rho s. So from this, en2 is normal component in medium 2 is epsilon en1 minus rho s by epsilon 2. So for option D it is 6, and for option 1 dn1 minus dn2 is rho s. It is rho s. So correct option is 1. Similarly, for magnetic field component, Bn1 is equal to Bn2. Normal component of magnetic flux density is continuous, and tangential component of magnetic field intensity is H2, Ht1, Ht2 is equal to A. This is discontinuous, continuous. Normal component of flux density is magnetic flux density is continuous, and magnetic field is discontinuous, where K is surface current density. K is surface current. This is related to magnetic field, and this is related to electric field. Tangential component of electric field is continuous. The normal component of electric flux density is discontinuous and is equal to rho s surface charge density. Surface charge density. Next question. These are the general boundary conditions. Tangential component of electric field is continuous. There is a discontinuity at the tangential H field across the surface current. Next, discontinuity at the normal d bar equals to surface charge density. The normal component of B is continuous. Next question. The Faraday's law defines electric field in terms of magnetic field. So Maxwell equations. Let us see Maxwell equations. So Gauss law in differential form, del dot D is equal to rho V, an integral form, surface integral of closed surface integral of d bar dot ds bar is equal to open volume integral of rho V dV. So that is volume integral of del dot D into dV, that is charge enclosed. Similarly, Gauss law for magnetic field, del dot B is equal to 0, closed surface integral of B bar dot Bs ds bar is 0, non-existence of isolated magnetic field. Next is Faraday's law, del cross C is equal to minus dou B bar by dt, dou T, differential form, and integral form is closed line integral of B bar dot dl bar is equal to minus dou by dou T of open surface integral B bar dot ds bar. Ampere circuit law, del cross H is equal to Jc plus dou d bar by dt, where Jc is a conduction current density and Jd is a displacement current density. So in integral form, line integral of H bar dot dl bar is open line closed line integral open surface integral of J bar plus dou d bar by dou T into ds, where J is sigma e and Jd is dou d bar by dou T. Therefore, this Ampere circuit Ampere's law defines curl of magnetic field in terms of displacement current density. This statement is correct. Statement P. Faraday law defines divergence of electric field in terms of magnetic field. So wrong. Faraday's law explains how magnetic field interacts with. It explains how magnetic field interacts with electric field. The interaction of magnetic and electric field is given by Faraday's law. It defines a divergence, not curl of electric field in terms of magnetic field. Del cross E is equal to minus dou B bar by dou T. So the curl of electric field in terms of magnetic field. So correct option is 1. P is incorrect, Q is correct. Next question. The electric field and magnetic field components of TEM wave is given as Ex is equal to Ex naught cos omega t minus beta z, Hy is equal to Hy naught cos omega t minus beta z. So from this electric field equation and magnetic field equation, the electric field component is in positive x direction and magnetic field component is in positive y direction. So they ask to calculate the direction of power. So direction of power is direction of signal propagation. So from this expression, AE cross AH is equal to AP cap, that is X cap, multiplied with Y cap is Z cap. See now AP is the direction of propagation, therefore signal is propagating in positive Z direction. Signal propagation in positive Z direction, that is direction of propagation. So if signal is propagating in Z direction, the direction of power flow is also same. So the direction of power flow is same as the direction of signal propagation, that is positive Z direction. Next question. In the context of following component of a plane wave propagating in free space, so they have given Ex is equal to Ex naught e power minus alpha z cos omega t minus beta z. The wave is propagating in positive Z direction. It is correct. So let us see some points related to attenuation constant and phase constant. This attenuation constant alpha is a measure of spatial rate of decay of wave in a medium, that is given by Napier per meter, and attenuation constant is defined as the rate at which wave amplitude decays, rate at which wave amplitude decays as it propagates through the medium, as it moves through the medium. And phase constant or wave number is a measure of phase shift per unit length. So units for phase constant is radian per meter. This attenuation constant, the positive value of alpha, indicates attenuation of amplitude with respect to time. The amplitude of wave varies with time as a result of attenuation, and this variation is exponential. So this attenuation of a wave depends E naught e power minus alpha z. So it doesn't simply depend on alpha, but it is an exponential. Alpha is a constant. Alpha decreases the signal amplitude when propagating. Alpha depends on medium and frequency of wave. The amplitude of wave varies with time as a result of attenuation, and this variation is exponential. So statement Q is incorrect and statement P is correct. This attenuation simply doesn't depend on alpha, but it is an exponential. It depends on e power minus alpha. Next question. Let us see few points related to this optical fiber, construction of optical fiber. So in optical fiber, the innermost is protected by core is protected by cladding and then outer jacket. So optical fiber, where the light is transmitted in the core of the fiber, it works on the principle of total internal reflection, and the information is transmitted in the form of light, that is at optical frequencies. Similarly, waveguide confines and guides the microwave. It has two modes, either TE mode or TM mode of operation, but TEM mode doesn't exist in waveguides. Waveguide is an high pass filter that allows only frequencies above the cutoff frequency. The synthetic aperture radar is advanced radar imaging technique that uses moving antennas to create high resolution images. And this synthetic aperture radar is mostly used in airborne radars or surface borne radars, used in variety of applications including military, environmental and research. Now, this core and cladding are related to optical fibers. Synthetic aperture is an radar. So synthetic aperture is radar. Next, TE and TM modes are related to rectangular waveguides, and directivity is related to antenna. This directivity, direct to gain, radiation resistance, radiation radiation resistance, directivity, direct to gain, maximum direct to gain is directivity. So direct to gain, half power beam width, gain, all these are the parameters related to antenna. So correct option is 1. Next question. Consider an electric field component Ex is equal to 0.2 cos 2 pi 10 power 60 minus 0.2 Z. So compare this given electric field component with standard component Ex is equal to Ex naught cos omega t minus beta Z, where beta is a phase constant and omega is the angular frequency. So from this expression, omega is 2 pi f, that is 2 pi into 10 power 6. Now we know that phase velocity Vp is omega by beta, that is 2 pi into 10 power 6 by beta. Beta value is, from the expression, beta is 0.2. So on calculation, this value is 3.14 into 10 power 7, 3.14 into 10 power 7 meters per second. So the value of pi is 3.14. Correct option is 1. Next question. It is related to complex permeability. Complex permeability mu c, it is given as it consists of real part as well as imaginary part component. So mu dash is real part of permeability that affects the speed of wave in medium, and mu double dash is imaginary part that contributes to the loss in the medium. This attenuation, signal attenuation, is directly proportional to square root of imaginary part of complex permeability. So imaginary part larger the mu double dash imaginary part, larger the imaginary part of complex permeability, higher will be the attenuation. Higher will be larger the imaginary part of complex permeability mu c. If this mu c is larger in this complex permeability, then attenuation will be higher. This complex permeability exists in ferrites, thin films of iron, cobalt, nickel, metametals. So metametals means EM wave absorbing metals. So these are electromagnetic wave absorbing metals. So these are used in stealth technology fighter jets. Next is, this complex permeability exists in YCBO, yttrium, barium, copper oxide superconductors, and ionized gas, etc. So correct option is complex permeability is one of the reasons for wave loss in the medium. Statement P is correct. Ferrites have complex permeability. So statement B is also correct. So statement Q is also correct. Both statements are correct. Option 1. Next question. What is the depth of penetration of a wave propagating? They have asked the formula for skin depth. Skin depth is a measure of depth to which an EM wave can penetrate in the medium, or the distance through which wave amplitude decreases to a factor of e power minus 1. That is 37% of the distance. One more definition is the distance through which wave amplitude decreases to a factor of e power minus 1, that is 37% of original value, is called skin depth or depth of penetration. This skin depth, it is given as delta is equal to 1 by alpha. Alpha is attenuation constant, so 1 by square root of pi f mu sigma. Alpha is given as square root of omega mu sigma by 2. Its value is square root of pi f mu sigma, where sigma is the conductivity of material, mu is permeability, f is of operating frequency. So this skin depth delta is equal to 1 by attenuation constant. So correct option is 1. Next question. Compute the propagation constant for lossless transmission line. So propagation constant gamma is given as square root of r plus j omega l into g plus j omega c, where r is the resistance per unit length of a transmission line, l is the inductance per unit length of a transmission line, g is a conductance per unit length, and c is the capacitance per unit length of transmission line, and omega is the angular frequency. Also given the line is lossless. For lossless transmission line, r is 0 and g is 0. So gamma is square root of j omega L. L is inductance per unit length given 2 Henry per meter, and C is capacitance per unit length given j omega C. C is 2 farads per meter. So its value is j square omega square into 4, that is 2j omega. Correct option is 1. Next question. The characteristic impedance of a transmission line given R, L, G and C operating at 1 radian per second. So characteristic impedance of a transmission line is a ratio of positively traveling voltage wave to current wave at any point on a transmission line. So this characteristic impedance is a resistance that would exhibit if the transmission line was of infinite length. So Z0 is not a resistance or impedance in traditional sense, rather it is a complex quantity that represents a relation between voltage and current for a traveling wave on a line. This characteristic impedance is a complex quantity that represents a relation between voltage and current for a traveling wave on the line. Z0 is defined as a ratio of positively traveling voltage wave to positively traveling current wave at any point on the line. This characteristic impedance is given as Z0 is equal to square root of R plus j omega L by G plus j omega C. So compare the values in this expression. I mean, substitute the values in the given values in the characteristic impedance expression. Then we will get R is 2 plus j omega L is 1 divided by G plus j omega C. On calculation, we will get 1 ohm, characteristic impedance of 1 ohm for the given values. Next question. Transmission line has S11 is equal to S22 is equal to 0. So S is a scattering matrix. S11 is reflection at port 1, S22 is reflection at port 2. If S11 is equal to 0 and S22 is equal to 0, so that means the diagonal elements of scattering matrix are 0, implies diagonal elements of scattering matrix is 0. So if all diagonal elements are 0, then it is perfectly matched line. Perfectly matched line. So if a line is perfectly matched, then no reflected wave. That is, entire wave is transmitted. It represents a ideal power transfer with no energy being reflected back into the system. For a scattering matrix, if diagonal elements are 0, then it represents ideal power transfer with no energy being reflected back into the system. So it is a perfectly matched line, no reflected wave, and entire wave is transmitted. So perfectly matched line means ZL is equal to Z0. So no reflection. No reflection means gamma is 0. So gamma 0 means ZL minus Z0 is equal to 0, implies load impedance is equal to characteristic impedance. Load impedance is equal to characteristic impedance. Next question. In a Smith chart, constant R circle R is equal to 0 corresponds to. So when a Smith chart, if R is 0, radius of the circle is circle radius is equal to 1 by 1 plus R, and center of the circle is R by R plus 1 comma 0. Constant resistance circle R is equal to 0 corresponds to R is 0. So if R is 0, then radius is 1, center is 0 comma 0. It represents short circuit load. For short circuit load, ZL is 0. If ZL is 0, gamma is equal to ZL minus Z0 by ZL plus Z0. Gamma value is 1. So in this expression for gamma, replace ZL is equal to 0. From this, gamma value is minus 1. So mod gamma is 1. Option 1 is correct according to the question. Similarly, if r is equal to infinity, then radius is 1 by 1 plus infinity, that is 0. Center is infinity by 1 plus infinity, so that is also 0 comma 0. Center is also 0 comma 0. Take r common, then center will become 1 by 1, 1 comma 0. Center is 1 comma 0. So infinity by, take r common, 1 by, so if you take r is common, r into 1 by r into 1 by 1 plus r. If r, this r get cancelled, so replace infinity here. 1 by infinity is 0, 1 by 1 is 1. So center is 1 comma 0. In this case, it represents short circuit load for a open circuit load. Open circuit load. So for open circuit load, ZL is infinity. If ZL is infinity, then reflection coefficient gamma is plus 1. So its value is plus 1. On a Smith chart, reflection coefficient of 0 is represented by the center of the chart, and reflection coefficient of plus 1 is represented by the outer circle. For open circuit load, the circle degenerates to a single point because radius is 0. The circle degenerates to a single point centered at 1 comma 0, and the radius of 0, which is at the radius of 0 at which the entire incident wave is reflected totally. Sim- Next, take constant resistance circle of r is equal to 1. With this, for this case, radius is 1 by 1 plus r, 0.5, and center is 1 by 1 plus 2, that is 0.5 comma 0. So in this case, reflection is 0 because load impedance matches with the characteristic impedance. So this is a case r is equal to 1, constant resistance circle of r is equal to 1. It is a case for which reflection is 0. So this is a case for reflection is 0. Next, if small r is infinity, mod gamma is 1. If small r is 0, then mod gamma value is 1 and gamma is minus 1. These are the three different cases. Mod gamma is equal to 0.5 is represented by the point halfway between center and perimeter of the chart. On a Smith chart, reflection coefficient of 0, mod gamma is 0, represented by the center of chart, and reflection coefficient of 1 is represented by the outer circle. In a Smith chart, constant resistance circle corresponds, r is equal to 0 corresponds to load impedance that is purely reactive, either inductive or capacitive. At this point, reflection coefficient has a magnitude of unity. No power is transferred to the load. Completely, the signal is reflected back.